Okay, cumulative frequency graphs, very popular. They come up pretty much guaranteed every year. Sometimes you have to draw the graph yourself. With a question like this, the graph is already drawn for you, and what they're asking you to do is interpret it. The context of this question is the time taken in minutes by 120 people to complete a task, and this is the polygon that's produced. So this is a typical cumulative frequency curve. It's always increasing from 0 up to the maximum, and the maximum is the total number of people or the total data items that it represents. So we've got 120 people there, and you can see that the axis goes up to 120. The first thing we need to do is to use this to find the median time taken to complete the task. Well, median as a measure of average is the halfway point. So if we have 120 students, then 120 people, then half of that is 60. So we'll find the median time by going up this axis to 60 and across to the graph. And as far as an exam goes, it's always worth you marking this on. So this is going to be where we find our median. So 60 isn't the answer, 60 isn't the median, 60 is where we go to get our median. So we draw the line across to the curve and then we read that vertically downwards. So this value is what our median is. Okay, now this copy hasn't come out very well, but what we're looking at here is one little square representing 1 minute. So what we've got there is 30, 31, 32 minutes. Second part of the question is how many people took more than 38 minutes to complete the task. So they're giving us a time, so we have to start off on this time axis, and what we need to do is to read up to the curve and across. So 38 minutes is going to be around there. So again, with my ruler, read up to the curve. So I've got arrows on now to show the examiner that I'm heading in that direction, and then across to there. So the value that I'm reading off the graph is 100. But the way that a cumulative frequency graph works is that represents the number of people that finished it in less than 38 minutes. Okay, it always reads less than. So if 100 took less than 38 minutes, it's this amount of people that took more. So the number that took more than would be 120 less than 100. 20 people took more. Okay, so off the graph, in one direction, you're going from the halfway point of the people and reading off their time, and then for the second part of the question, you're starting with time, which is this axis, reading up and across, but remember that that value there is telling you how many got less than that rather than more. Okay, the second question that we're looking at here, again they've drawn the cumulative frequency total for you already. Context of this question is mass. The masses of 300 pupils were measured in kilograms. So again, that means that this graph is going to go up to 300. Use the cumulative frequency polygon to find the interquartile range. In the previous question we found the median, which is the halfway point. The interquartile range is the difference between two other values, the lower quartile, which is at a quarter of the value, and the upper quartile, which is at 3/4 of the value. So a quarter of the value, halfway would be 150. Half of 150 is 75. So the interquartile range, the lower quartile, we'll find at 75. Now, if we look at the scale that's going up here, each little square is 10 squares between 0 and 50. So 50 divided by 10 is 5. So each little square is 5. I need to find 75. So 50, 2 squares 60, 2 squares 70, and one more square 75. Read that across to your graph, and that's the lower quartile. So I'll put LQ there. So the lower quartile, and read this off. So I'm reading down to there, and in this direction 10 squares is 5. Okay, I'm going from 45 to 50 in 10 little squares. So if 10 squares is 5, 5 divided by 10 is a half. So each little square now is worth a half, or 2 squares is 1. So I go in 45, 1, 2, 46, 1, 2, 47, 1, 2, 48. So the lower quartile value is 48. So the upper quartile is going to be at the 3/4 point, and the 3/4 point is going to be 225, which is going to be halfway between those two. So 200, 210, 220, 225 is there. Get your ruler. Draw across and put UQ there to show that you're now measuring the upper quartile. And that is going to be 61. So upper quartile is 61. So the interquartile range is the difference between the upper quartile and the lower quartile. That comes to 13. Okay, the bigger that is, the bigger that value, it means that the more spread out your data is. And then part B, how many pupils have a mass greater than 58? So same as with the previous question now, the mass axis is this one. So I need to find 58 along here, 55, 56, 57, 58. Draw up this time, so arrows going that way. Read across. And the examiner will be allowed to give you a range of answers here. So if your measurement is slightly different to mine, it's not the end of the world. You'd probably still be acceptable. It's the method they're more interested in. So what we're reading off here is 100, 200, and so 190. So 190, but remember cumulative frequency measures less than. So 190 pupils had a mass less than 58 kilos. So it's the difference between the 300 which is 110 pupils, oops, weighed more. Okay, so same again. This time it's interquartile range rather than median. So you need the quarter of 300, 3/4 of 300 to get the upper quartile. Read those values off the graph, take them away, it gives you the interquartile range. And then the second part of the question, you have to go in the other direction and remember that that value there is less than, so you have to take it away from the total. Alright, so with the third question, we have to draw the graph ourselves. So let's look at the context. A task was given to 60 volunteers, and the times they took in seconds to complete the task were recorded. So here we've got 60 volunteers, so the total in the cumulative frequency should be 60, and that's what our graph is going to come up to. So to draw this graph then, we start off with a cumulative frequency of 0, and the time taken to complete none of them took less than 15 seconds. So 0, 15. Then we've got 20 seconds with 3 students. So 20 seconds, check the scale here. We're going from 0 to 10 in 10 little squares. So each little square is 1. So 20, 1, 2, 3, put across. 25 is 9. 30 is 18. 35 is 37. 40 is 52. And 45 is 57. And 50 is 60. Now it's important that when you draw your line or your curve, those points can still be clearly seen by the examiner. So it's well worth you putting a little cross like I've done rather than a dot, which will be covered by your pencil. Now you can join these up with a ruler, but I prefer to use freehand. So it's just a case of joining the dots. And getting a feel for what the curve should look like. It's not the end of the world if you've got the odd little blip in it like mine seems to have there, and I've slightly missed that point there, but it's quite clear what I was trying to do. This question again, same as the last one, they want to find the interquartile range. This time it's going to be the quarter of 60 and 3/4 of 60. So half of 60 is 30, half of 30 is 15, so the quarter way will be 15 there. So this will be your lower quartile. Use a different colour. And again, put your arrows on so the examiner knows which direction you're travelling, and write LQ, lower quartile, and read down your graph. So the lower quartile, LQ, is going to be 25. So in this scale we're going from 15 to 20, so 5 seconds in 10 jumps. So 5 divided by 10 is a half, so each little square is a half. So 1, 2, 26, 27, 27 and a half seconds. Upper quartile will be at 45, 3/4 of 60. UQ, there we go, upper quartile. Read down your graph. And we've got 35, 36, 36 and a half for upper quartile. So the interquartile range is 36 and a half, take away 27 and a half, which is 9 seconds. Okay, moving on. Okay, so with the next one here, we're actually having to complete the cumulative frequency diagram table ourselves as well. It's telling us the heart rate of 80 people here, so this final figure needs to be 80. So long as we get 80 there, we're going to do it right. And the way that this is completed is it'll be a running total of these figures here. So we know that 3 people had a heart rate between 80 and 90. So here, 3 people have got a heart rate of less than 90. Now if I'm talking about a heart rate less than 100, then that's going to be those 3 and that 12, making 15 there. So a heart rate of 110, less than 110, is going to be that and that and that. Okay, or 15 and 21. 15 and 21 is 36, so we're going to have a 36 in here. And then the next one is going to be the running total to there plus 36, so that's going to be 72. And then 72 and 7 will give us less than 130, which is 79. And then finally add that one there, which is 80. So that and that are the same, so I know that that's 80, that's correctly completed, and I know that my cumulative frequency curve is going to end up at the top there. So now we draw the curve. Heart rate less than 90 is 3. Now here, each little square, we're going from 0 to 10 in 10 jumps, so each little square is 1. So 90 is 3, is going to be about there. And then 100 is 15. 110 is 36. 120 is 72. 130 is 79. And 140 is 80. Then again, either using a ruler or freehand, we complete the curve. So there you go. We don't know what happens, nothing less than 90, so we just leave that from the first point. And once again, interquartile range. So we need a quarter of 80, which is going to be 20 for the lower quartile. So I'm going from 20 across LQ, lower quartile, and read down off your graph. Work out what the scale is here. We're going from 100 to 110 in 10 little squares. So each little square is 1. So the lower quartile there is going to read off as 102. As I said earlier, it doesn't matter if you've got 103 or 104, that will be alright. Upper quartile will be at 3/4 of 80, which is 60. So we go up to 60, across the graph, UQ, upper quartile, and read down. So the upper quartile, you can see there, is 115. So the interquartile range is 115. Oops. Take away 102, which is 13. So hopefully by now you're spotting that these are very repetitive questions. If you can get your head around how to do them, you can pretty much answer any one. Okay, but 2 more to do. Okay, with question 5, there are 2 graphs, 2 cumulative frequency curves drawn on the same axis. So chances are we're going to have to do some comparisons here. So the context of this question then, 2 clinics labelled A and B record the waiting time in minutes before treatment for each of their 120 patients. So you can see they're both going up to 120. Cumulative frequency polygons for waiting times at clinics A and B are shown below. Use the cumulative frequency polygon to answer the following questions. Find which clinic had the shorter median waiting time and by how many minutes. Well, the median waiting time, median is halfway, so halfway of 120 is going to be 60. So for clinic B, we're going across to there, and that's going to tell us that the median waiting time for clinic B the median waiting time is, and here we're going from 15 to 20 in 10 jumps, 5 minutes in 10 jumps. So each jump, each little square is going to be half a minute. So clinic B is going to be 15, 16, 17, 18, 18 and a half minutes. Clinic A is further along. Clinic A here has got a median waiting time of 22 and a half minutes. So the clinic with the shorter median is B, and that's going to be by 4 minutes, the difference between the two. So clinic B shorter by 4 minutes. At which clinic are you more likely to have to wait longer than 30 minutes before you were treated? So 30 minutes, so what we've got to do here now is go across to 30 and read up your graph. Okay, and then we'll read them off and work out what that's going to tell us. So 30 minutes is there. So reading 30 minutes off our graph is telling me that the clinic A so clinic A, we're going on this scale, we're going from 0 to 20 in 10 jumps. So each little square is going to be 20 divided by 10, 2 minutes. So we're going to go 80, 82, 84, 86. So in clinic A, (86) out of the 120 waited less than 30 minutes. Okay, remember it's always telling us less than. So in clinic A, we've gone up from 30, read across, 86 people waited less than 30 minutes. Now in clinic B, if we keep this line going up as far as clinic B, so we're reading it that little bit further, and read across, then that's going to be 112. Out of their 120 waited less than 30 minutes. So how does that relate to the question? At which clinic are you more likely to have to wait longer than 30 minutes before you're treated? Well, in clinic B, nearly all of them waited less than 30 minutes. In clinic A, only 86 waited less. So more of those had to wait longer. So clinic A is the answer. So more likely to wait longer than 30 mins in clinic A. Okay, let me just make sure you're happy with that again. 30 minutes, reading off the graph, clinic A, 86. So 86 patients had to wait less than 30 minutes. In clinic B, there were more patients that had to wait less. Okay, so I can see that could be a bit confusing. So as far as waiting longer, there's more people in clinic A that have to wait longer. Okay, and the final question, again, is a comparison one. Context here, we've got the length of time taken by two different groups of 50, so there's 50, to complete a task successfully. State which group of students, A or B, was quicker at successfully completing the task. Give a reason for your decision. Well, when they've all finished, they get to there. So you can see here that group A, they all finished by that point there, which is, so group A, sorry the pen is bleeding, group A all finished by that point, okay, which is, what are we going up here? We're going up 5 in 10, so the half, so that's 15, 16, 17 minutes. Group A all finished after 17 minutes. Group B stopped there, they all finished after 20 minutes. So, which group was the quicker? A. And the second part, state the median of the times taken for successfully completing the task for group A. Median, halfway point, halfway for 50 is 25. So we need to read off from 25 to group A, which is there, and read down from there. And that each one of these is a half, so that's 7.5 and a half, 8 minutes. So that's your cumulative frequency.